Hello and welcome everyone. My name is Kelly here with Esri and I would like to welcome you to our webinar today, Enhancing Collaboration for Obstacle Assessment. And with that, I'll go ahead and turn it over to our first presenter today, Jonathan Weaver.
Great, thank you, Kelly. Well, this is the first webinar in a series, and I'll highlight some of the other upcoming subsequent webinars later, but like I said, this is the first in a series. My name is Jonathan Weaver. I manage our aviation business development for Esri, and I'm joined by a couple of my colleagues, Amit Jain, who's the product manager for ArcGIS Aviation, as well as Kiyoshi Yamashita, who is in professional services for aviation as well. So what does it really mean to enhance collaboration for obstacle assessment? It's about shared knowledge of data and information, so making that information accessible to stakeholders when evaluating those obstacles. Obstacle assessment can't be conducted in isolation and needs input from multiple departments. So in this webinar, we're going to take you through the steps of an evaluation, how we can actually connect this to a larger system of stakeholders. So why do we even collect obstacles? Well, besides ICAO telling authorities that they need to for their ETOD initiative. And for those that are unfamiliar with ETOD, ETOD is electronic terrain and obstacle data. It provides accuracy requirements for collection of obstacle and terrain data specific to really 4 distinct areas. What they call Area 1, which is the entire state or country, and then Area 2, which is actually divided into kind of sub areas, but essentially is the TMA that goes out to about 45 kilometers around the airport. And then Areas 3 and 4 are really isolated to kind of the surface movement areas of the airport and really the precision end of a runway. So all of this data supports ground proximity warning systems and aircraft operating limitations, even design of instrument flight procedures and aeronautical chart production. However, in addition to the ETOD collection, there's regulations in place for construction or alteration of structures that have an impact on the navigable airspace. And that's really what the focus of this webinar is on that particular process. So regardless if you're dealing with ETOD or the control of obstacles, all of this is really to enhance safety of aircraft operating around the airport airspace. ArcGIS provides an ideal platform not only for obstacle assessment, but also for all of an authority's geospatial needs, from the collection of information in structured or unstructured formats to real-time observations, CAD and BIM data, even field applications. All of that is to collect information so we can do something with it, so we can really understand the relationships between some of the information that's being collected. So whether it's for obstacle assessment or route optimization, or even noise analysis and noise mitigation efforts. Once we do the analysis, we typically want to produce some sort of information product. So the information product can be in kind of the traditional hard copy charts, obstacle type A chart, for example. It could be web applications and web services that are published to even dashboards that provide high-level insight into operational efficiencies for an organization. And then ultimately, how do we share this information across the organization to the various departments, whether it's planning or air navigation, to weather, operations, facilities, and really to all of our stakeholders. It's this collaboration at scale, which is really important. And we have a lot of tools and applications that support this highly connected environment for aviation. We also have some very specialized tools specifically for aviation, and this is where we're going to spend a significant amount of time today, is really in the ArcGIS Aviation Airports product. So when we talk about ArcGIS Aviation Airports, we actually have kind of distinct buckets that we work in. One is Airports GIS. This is really about having an established data model that is compliant with certain industry regulations, being able to collect data into that data model and actually do some validation against those same standards. On the far right, we have signage and marking tools that allow our users to develop templates and to develop plans that are submitted to authorities as it relates to the signage and markings of airports. And then finally, the obstacle analysis, and that's what you see in the center. And that's going to be really the focus of much of today's discussion. When we talk about obstacle management, kind of 3 buckets we put things in. The first is the creation of those 3-dimensional surfaces. We can create these surfaces according to various criteria or specifications. The first is ICAO, the International Civil Aviation Organization. in accordance with their Annex 14 and Annex 15. For our US customers, we have FAA criteria, that's Part 77, or advisory circulars for 13A and 18B. In addition to the ICAO and FAA criteria, we also have the ability to create surfaces against the communication, navigation, and surveillance surfaces, as well as PAPI surfaces. All of the surfaces that we can create within the tools are also configurable, meaning we expose a lot of those parameters that are associated with the various specifications, ICAO or FAA. So, for example, if you need to change the slope of a departure surface, we can expose those parameters through a nice little GUI, so it makes it easy to expose those parameters, make modifications, and actually leverage those for specific cases. And then once we can create our surfaces, the next step is to really automate the analysis. So taking our points, lines, polygons for obstacles, analyzing that against the surface to see what's penetrating and what's not, even extending that to LiDAR data sets. And then once we've done that, typically what we want to be able to do is share the results internally or even perhaps externally. And there's a lot of tools, and we'll show some of these tools to be able to share those results. So before we move into some specific demonstrations here, I'd like to kind of put things into context and frame things. So we saw the geospatial cloud for aviation slide that talked about collection, analyze and producing information products. Putting this into the context of obstacle evaluation and management, what we'll be doing and kind of running through the various demonstrations is showing you how we collect information, various means of collecting it, whether it's through a dedicated web application or even what we call a survey form, to obstacle files. So commonly what we see are Excel spreadsheets that are provided. We need to be able to consume those spreadsheets, create actual geographic data from it so we can then analyze that information. And then we'll do some of that analysis all within ArcGIS Pro using the airport solution, creating the airport surfaces. I think Amit's going to actually show you how to create a CNS surface as well. And then we'll go through and actually create some of the information products, type A chart, for example, and then sharing some of this information and making it available to a larger audience and organization. And then kind of the last piece is how do we wrap this within a workflow package? And so using some of the workflow tools to manage these pieces of work and then ultimately reporting on that through some dashboards. All right, so that brings us to the kind of first of a series of demonstrations here. Like I said, what we'll show in this first set of demonstrations is obstacle collection using one of our applications called Survey123. We'll then import an obstacle file and do some of the surface creation and analysis against our obstacles. So what I have right now is a Survey123 form that I've authored, essentially just configured. So there's no back-end coding that was necessary. I was able to go through and actually decide, okay, what are the key pieces of information that I want? In doing so, I've connected this to a hosted feature service. So by doing that, Amit's going to have access to that feature service. He can do some analysis against the feature service. I can also bring that into other applications and web apps to do some visualization as well. So in this case, I'm just going to go through this form. This is a form that we would typically expose to a company who's looking to construct a tower or some kind of building that may impact some of the navigable airspace around an airport. So as I go through this, I'll just go ahead and enter my name, enter an email address here. Maybe I'm going to construct a tower, a cell phone tower. In the area that I'm going to build it, I know the ground elevation is about 3 meters, and we're going to construct it at a height of 51 meters. It'll be a fairly large tower or high tower. Okay, so I've also got an option whether it needs to be lighted or not, and I can indicate any number of fields that are relevant for the collection of this type of information. But one of the more important pieces of information is actually where is the tower going to be located. So I can actually go in and navigate through the map here and just drop a point. That's one way of doing it, but more than likely, company's going to have a specific set of coordinates they're going to want to use. So I'm just going to copy and paste some coordinates here. If we zoom in, we'll see that's actually kind of located on this peninsula in the center of this roundabout. So I'll go ahead and let's see, use today's date, go ahead and submit this. This is actually creating a feature within this feature service that we'll have access to kind of throughout the demonstration. So this is one mechanism of actually collecting data digitally from customers so we can actually do the obstacle analysis. Now I'm going to turn it over to Amit, who's going to take us through the importing of an obstacle file, and then for the rest of the demonstration, so how he can create some of the surfaces and do some of the surface analysis against those obstacles. So Amit, why don't you take it away?
Sure. Thanks, Jonathan. So here we have the San Diego Airport. So you can see some of the runway and the markings that we have for the San Diego Airport. So as Jonathan mentioned, that our obstacle data can come from various different sources. So here I have an Excel file which has my obstacle survey data. So if we look at the Excel file real quick, we have certain information like elevation value, height, some accuracy, and the type information for those obstacles. So what we're going to do is we're going to go ahead and import those obstacles. So I'm going to point to my Excel file. This is my obstacles. My sheet name was obstacles. For the coordinate system, I'm going to choose the coordinate system of the database because the XY coordinate we had were in meters. So I'm going to choose the state plane coordinate system. And for destination, we're going to choose the vertical structure point that we have loaded in this map itself. So I'm going to go ahead and start loading this database. So as we're loading it, it's important to understand the information that's being loaded or the information that's present in your survey data. So here we can see our elevation value and height. And I can tell that elevation value is information that is collected at the top of the obstacle. So this information would be really helpful when we're doing our analysis. So we understand how our data was collected. So when we do our analysis, we can make those selections and those information can be used. So if I click on any of the point, I can get some information about what elevation value is, what the surface type is or surface material is, and what the type of the obstacle is. It's a sign feature. So let's go ahead and create some surfaces next. And what we're going to do first is we're going to create some ILS surfaces. So I have a Navid here, which is of type localizer. So I'm going to create a CNS surface for that. So the way we create our surfaces would be to go through our edit and create features menu. And I'm going to be creating my surfaces in a multi-patch. So when I click my multi-patch template, you can see various tools that are available to generate your multi-patch surfaces. And here we have a tool to create our CNS surfaces. So let me select that as my template. And here I'm presented with two different options. So if my facility is omnidirectional, then I can choose the specification for the facility, whether it's the communication, navigation, or surveillance, and choose my options according to that. But in this case, it's a unidirectional facility, and I know it's my ILS feature. I'm going to give the facility direction, which is 286, and the rest of the parameters are coming from the specification, so I'm not going to change those. So the first thing it's asking me to do is to select my facility location. So I'm going to select my Navid system point, and then it's asking me to select my threshold location. So I'm going to select my threshold. And just by clicking that, it created my surfaces based on the parameters we had saved or set up. So here is our CNS surfaces really created really quickly. So I'm going to save my changes. So the next thing we are going to do is create some of those obstacle surfaces. So I'm going to go to my geoprocessing. This can be launched through my analysis and tools. And I'm going to go to my aviation toolbox. In there, we have airports. And in here, we have different tool sets. So I'm going to go into my obstruction identification surfaces. So as you can see here, we have different specifications that are available with the airport solution. So I'm going to choose IQNX14 for this demo. When we launch the tool, we are presented with certain options. So the first thing I have to select is my runway features. So I have my runway centerline information here. Choose the target OIS feature class. So we do support multi-patch and polygon as an output for our OIS surfaces. We recommend using multi-patch because it's the most accurate for any analysis you want to do. But if you are just using it to do some two-dimensional maps and just showing it in two-dimensional view, then you can choose polygon as well. The next thing I have to select would be the classification. So this is based on IQNX 14. So for this runway, I'm going to choose non-instrument code number 4. And then we have certain parameters which are dependent on the runway. So if I have a clear way, I can enter that. Airport elevation, I can enter it manually, or I can also provide my airport control point feature class. In this case, I'm just going to manually put that information. And then depending on a type of your runway direction, I can choose that as well. And here's that custom information that Jonathan talked about how we can customize the parameters. So we can provide that as well. So I'm running the tool, and it should create pretty quickly. And here we have all our OIS surface created. So once we have the OIS surface created, the next step would be to start working with our analysis. So I'm just gonna focus on my approach surfaces here, and we can actually visually see there are some penetration of OIS surfaces. So we're gonna run our analysis against this OIS surface. So to do that, we go back to our toolbox, and this time I'm gonna open my analysis tool set. And in here, I'm gonna do analyze runway obstacles. So for all of our analysis tools, the input would be our OIS surface. In this case, it would be the multi-patch. For obstacle, I can choose either point, lines, and polygons. We have loaded data as our point obstacles. So I'm going to choose that. For my output, I'm going to name an output. So it's webinar 2020. And here we are presented with certain options about the information about the obstacles we are evaluating. So one of the first questions they ask is how is the obstacle information collected? So is it at the absolute height of the obstacle, or is it relative to the ground? In our data, we saw that elevation was collected at the top of the obstacle, so we can just choose that and choose my feature geometry, since the Z values were also at the top of the obstacle. But in some cases, and we understand that we are getting data from various different sources, so there might be a case where we have data coming as relative height. And in that case, we can say my height above the ground is coming from height value. The unit of my height was in meters. So as Jonathan entered, he was entering his height in meters. And then my elevation. In our case, the elevation field, if we see the options, we have elevation value and height value, but our elevation was collected at the top of the obstacle. So I can also utilize the digital elevation model to get that information. And in our database or our map, we have a DEM for San Diego. So I'm just going to use that. So it's going to get my ground information from this DEM. And let's run the analysis. So as we're running the analysis, what we're trying to do is we are trying to get obstacles that actually intersect with the two-dimensional extent of the OIS surface. And for those features that intersect the extent, we're going to do the analysis about what the penetrations are. So here we can see it selected some of those features. And let's see what the output was created. So it found 6 different features. All of them were intersecting our approach surface because that's the one we selected. Then we have information, which is delta Z. So delta Z is the amount of intersection or penetration we have from the obstacle. Anything that we have negative, that means it's below the surface. If it's positive, that means it's above the surface. Then we have information about the ground height at that value, height of the obstacle, and the height of the surface at that location. And we have some information about runway in the data set itself. So we can see how we have symbolized it. I can see it in a profile view. So we can see here, we have some obstacles that are not penetrating, but we do have a couple of obstacles which are penetrating. So now what we're going to do is we're going to do our analysis on LiDAR features. So here's the LiDAR that I downloaded from NOAA website, and this is for San Diego. So here we can see all the different details we have for the San Diego downtown. So what we're going to do is we're going to analyze this LiDAR data against our OI surface. So in our analysis toolset, we're going to open analyze last runway obstacles. We're going to start again providing the information. So I'm going to analyze against my OI surface, my LiDAR data, and my target would be webinar and demo. So let me kick this off, and we're going to talk about some of the information we have. So we have this vertical clearance. So in the case where you have your LiDAR data collected for vegetation and you want to understand if there is going to be penetrations because my trees are growing with a certain rate, so you can give this clearance to provide more information about what kind of intersection could be there in 3 to 6 months. We do support outputting as a feature class or as a last data set. In this case, we chose to output as a last data set, but you can also output as a feature class. And in that case, any of the LiDAR points that actually penetrate the OI surface would be written out to an obstacle point. So let me turn off my LiDAR data set, and now we can see all the points that it determined that were intersecting the surface. And when we look at the details, it took us 17 seconds to analyze all those LiDAR points. And in my existing data, I had close to 5 million points that we just analyzed, and it found close to 55,000 points that intersect. And it's pretty quick when we run through LiDAR, and you can see all the information that it's present. So as you're flying through San Diego, we need to watch out of those obstacles, and there might be an airplane also on the way. So just watch out for that. Back to you, Jonathan.
Great, thanks, Amit. So just kind of to recap what you saw here in this first segment. Actually, can you go back to the other slide, Amit? So coming back to this, we've got the collect, analyze, produce, share, manage. We focused on the collection and the analysis piece. These are essential pieces, but it's only part of the full chain that we want to show here. So next, as we move in kind of to the next phase of the demonstrations, we will focus on the produce, the share, and ultimately the manage on that. So now you can move to the next slide. So in this next segment, what we're going to show, Amit's going to show you how to create a type A chart, obstacle chart. Create that along with essentially that profile graphic that goes along with it. That's one information product that we can create, but he's actually going to take it a step further and actually create some or publish some services, some additional information products. So as a 3D scene that we'll be able to consume. And if things go according to plan, he will just paste that URL into the chat window for everybody to actually take a look at and spin around as well. And then how do we manage that process? So tying it into Workflow Manager and some of the dashboards. So yeah, Amit, why don't you go ahead and launch things off with the type A chart?
Okay, thanks, Jonathan. So I'm going to open my layout here. So here's a basic layout that we created. And all we had to do was like add certain scale bars, insert our legend, and we added our map frame, which in this case, we are focusing on the approaches around this runway center line. So the next thing we're going to do is add that profile view. So similar to other surround elements in a layout, we go to our insert menu and look for additional surrounds, and we have our aviation terrain obstacle profile. So what I'm going to do is I'm just going to drag a rectangle around here because that's where I want to place my terrain obstacle profile, and you'll see an empty graphic. So let me open the properties of this one, and we're presented with certain choices that we can start working through. So for my map frame, I'm going to choose my AOC map frame. In this case, I only have one map frame, but if your layout has multiple map frames, then you can choose the relevant one. For the profile chart, since we're creating our IQNX4 chart or type A chart, we're going to choose aerodrome obstacle chart. But if we're creating a precision approach terrain chart, we can choose that as the profile style as well. For our OIS type, we do support straight as well as curved. So in this case, this is a straight approach, so we're going to choose that. And the next thing would be our OIS surface. So this is coming from my multi-patch that we created earlier. So I'm going to choose that as my source. And as soon as we do that, we see our runway information and specification information get populated. If you have multiple runways, then you can choose which particular runway you are creating the surfaces for. And also, if you have multiple specifications or multiple OIS surfaces created, you can choose what would be your base specification, and all of the terrain and obstacles would be shown related to that, and other surfaces would be listed over here. We can also choose constant ratio to make sure our height and our horizontal and vertical extent are in a ratio to make it look nice and even. And then we do support a lot of options to allow to customize how we are showing our profile. So we have options to control how the extent of the grid is looking. You can control the symbology. For runway also, we have those certain options. For terrain, you can have options to choose to show everything. You can choose to show only terrain that is penetrating. So in this case, it just showed me things that are penetrating. Or if you want to highlight how your penetrating terrain is being shown, you can choose this option and it will show your things that are penetrating in a different color and things that are not penetrating with a different color. So we do provide a lot of different options to customize everything that you show here. But one of the most important thing that we do with this one is this element is dynamic. So as you're zooming around or panning around in your map, because that's the main area you want to focus on, you can see the graphic also updating as we start to move around. So here, as I'm moving or panning, the graphic updates. And once you're comfortable or you have captured the information that you want to showcase, you can go back to your layout view and you can share this out to a paper format. We have done similar kind of profile structure for our precision approach terrain chart, and we can create those kind of precision PETC style or IQNX chart with this one. But we can go a step further and we can actually share our analysis results as a web map so people can interact it in a digital form and not just look at it as a paper product. So here is the same LiDAR obstructions that we created earlier. And what I'm going to do now is use the capabilities with ArcGIS Pro to share it out to my portal and share it with everyone. So we go to share, click on my web scene, and I'm going to populate certain information. So my name is publish. Give it a summary, give it a tag. So people can search using this tag and provide a location. So you can choose to share with just a group you want to share or in your organization, or you can choose to share with everyone. In this case, I'm going to share it with everyone so everybody can take a look at it, and I can just click on share. So I have started the share. This process takes roughly a couple of minutes, so I'm going to hand it over back to Jonathan.
Okay, thanks, Amit. That's a lot of good stuff that you're showing here. All right, so let's see. So before we get to the scene that Amit is sharing right now, I wanted to take you to a specific example with the Panama Civil Aviation Authority. One of the reasons we want to publish these types of services is really so we can engage with our stakeholders, again, that's internally and externally. And I think this is a really good example of how the Panama Civil Aviation Authority, their Office of Standards and Operational Safety of Aerodromes, has worked with their local city planners in the design of this vehicle bridge across the Panama Canal. So as a part of this, so this is Marco Galiber Airport. Hope I didn't butcher the name too poorly, but it's already affected by a couple of natural obstacles, such as these hills to the right and left of the approach surface. And then there's some man-made obstacles and structures that are also penetrating as well. It's really a big challenge for the city, or for the Panama Civil Aviation Authority, to evaluate the design and construction of this bridge over the canal. It has hugely strategic importance, and it's a necessary piece of infrastructure for the country. And part of this bridge, they had over 1,300 different pylons and columns that they needed to evaluate. So they ran it through the system, the ArcGIS Aviation Airport system, to actually do the analysis. And out of that analysis resulted in about I think it was 130 obstacles that were deemed penetrating those surfaces. What was nice is that the CAA was actually able to work with the engineers to adjust certain parts of the design so it doesn't actually impact the critical safety areas for these Annex 14 surfaces. And so we can kind of zoom in and just look at various aspects. I've got, you know, a handful of bookmarks here to kind of show some of those penetrating obstacles you can see here, all highlighted in red. So that's certainly one way of leveraging this type of 3D scene for visualization to have a kind of a better understanding of the impact of certain structures, buildings, or even in road networks. So now, if things went according to plan, let me open up the chat here. I'm hoping Amit was able to paste the link. Were you able to paste the link into the chat window, Amit?
I just pasted.
Okay, awesome. Okay, I found it. All right, so let's go ahead and open this. This is what Amit had published as a part of his demonstration. We'll go ahead and open this up. Again, I'm just opening it up in a web browser. It's a nice way of being able to illustrate the impact of, in this case, it's LiDAR data set, in seeing the penetration that the LiDAR data set has on this particular approach surface. And what we can also do is actually change maybe the lighting to kind of enhance the LiDAR data set, even remove some of the shadows, and just kind of pan around. So you all have access to that. As Amit shared, he shared it with everyone. So you all should be able to access that without having to provide any kind of login. Okay, so that's the share component. Now we're going to transition a little bit into the workflow component. We want to be able to kind of wrap this up with some kind of workflow management system. And we do have, within the ArcGIS platform, there is a workflow manager application that we can use to help manage these discrete packages of work. So for example, Erlan, if I just refresh my screen here, hopefully we get, yep, there's the obstacle that I had submitted at the very beginning of the demonstration. So through that Survey 123 form. So with Workflow Manager, it's integrated into ArcGIS Pro very nicely. We'll be able to, that's going to enable us to actually track the work for the obstacle evaluation. If we can track it, we can report it. If we can report it, we can do a lot better job of in terms of management of how we manage the work packages that come in. How do we look for opportunities for creating efficiencies? So this is the obstacle that was submitted by a company. In this case, that company was myself on the peninsula here. What we would typically want to do is actually create a discrete package, a work package, so we can actually monitor the progression of this particular obstacle evaluation. So I'll just go ahead and select that, and in my workflow tab here, click on obstacle evaluation. So we've got different types of workflows that are part of the system here. A workflow means there's certain steps that are necessary for this particular work package. We have construction, data processing, chart production. They all have their own individual workflows that are associated with it. So we're going to stick with the obstacle evaluation. Let me refresh my screen here. I believe it was this work package here that was created, and this is the specific workflow. You can see that I've created it, so I can go ahead and just mark that step as complete. We've initialized it. We might have some preliminary findings that we want to include with this particular work package, so I can go into the descriptive information, type in any kind of descriptive information that's going to help with the overall evaluation and analysis of this. This might be deemed as a high priority, so we can change the priority. We can assign it to other users within our organization that are able to conduct this type of analysis. go ahead and apply those changes and then swing back over to the workflow here. So as we go through, and maybe I'll just kind of quickly highlight the overall workflow in this case. This is a configurable application, so we can actually configure the specific steps within the workflow. In this case, after we have our preliminary findings, we might dispatch the work to different departments within our organization. One for air navigation services review, so maybe procedure design, for example, the airport review, looking at the airport surfaces, and the CNS review. So we might find one of these and just say, okay, yep, this one's, we'll go ahead and mark this step as complete. Maybe even the CNS was complete, no penetration was found. However, maybe with the airport review, there was some penetration that was found. So we want to go into perhaps the history, for example, and then just type airport review, penetration of, let's say, 3 meters. So that becomes a part of the knowledge base for this particular obstacle evaluation. Also, you'll notice within the history, everything that's happening with the job, and I haven't done a whole lot with the job at this point, but all of that is being tracked. So we can actually, if there's issues later on in the process, we can go back and isolate, okay, well, where did this come from? What steps were completed? Who completed those steps? When were they completed? And again, it just adds to the overall body of knowledge for this particular obstacle evaluation. So that's one way of kind of wrapping all of this up with Workflow Manager. There is another component to this as well that we might want to involve, and that's using what we call dashboards. Dashboards give managers, executives, insights, excuse me, into really key operational metrics that are important for that organization. It tells them really the health of their business and how they're operating their business. So in this case, for obstacle evaluations, one of the key metrics for me would be making sure that we are executing and processing these evaluations in a timely manner. So on average, it's taking us just under 26 days to process a single obstacle evaluation. We want to make sure that we're basically doing that under 30 days. And in this case, we are. Some other key metrics that might be important is just understanding, okay, well, once obstacles or proposals have been constructed, we might need to go out and do some field verification. We have tools to do that through applications like Collector. But in terms of a dashboard, just kind of quickly seeing, okay, well, how many do we have? It's an interactive dashboard, so I can choose or click on the constructed, not verified, and quickly see all of those obstacles that have been constructed, but we need to send somebody out into the field just to do a verification of the final heights and maybe material makeup for that particular structure. And then, of course, any new proposals that have been submitted. So these, typically we would want to keep these down to a minimum and make sure that they're getting processed through the system. Again, all in the name of making sure that we're achieving this within an acceptable time frame for the duration of these evaluations. Okay. So let me switch back over to the slide deck here. There's quite a bit we showed. Again, from starting at the beginning with how we collect obstacle information to how do we analyze that, the different data sets that we can analyze. I know Amit focused on doing some of the point analysis from the obstacle file that he imported, also some LiDAR. In a recent meeting that we had, we were able to actually take in CAD files and directly bring that into Pro and do some analysis with those CAD files of the building structures. And then again, how do we produce different information products and share that across the organization and really just manage those work packages and the individual obstacle evaluations. So everything that we've shown you today is all a part of an initial operating capability for obstacles and ETOD. And when we talk about an initial operating capability, we're talking about a set of apps, information products, data model, and I'll use the term GIS-ready data. So oftentimes the reason that ETOD and obstacles makes a good initial operating capability, because obstacle data is, for the most part, relatively simple data to work with. Point obstacles is the most common type of obstacles that we encounter, but even if you have the lines, polygons, CAD, or even LiDAR, It's a relatively easy format of data to work with, so we can kind of launch our initial operating capability with that. And then Esri provides some support service to really accelerate that deployment. So this particular IOC, while easy to stand up and deploy, can bring a lot of value to the organization, whether it's for instrument flight procedure design, charting, permitting, or in some cases, you might want to make this data available through open data initiatives. Okay, so oftentimes we get asked, well, where do we begin with this? And we talk about deploying that initial operating capability that we saw in the previous slide. Once we deploy that initial operating capability, we can then go in and start defining what those workflows are that support the business processes and the business overall. We do that, we can then start to define those information products. And when I talk about information products, it can be a web map, it can be a 3D scene, it can be those dashboards that I showed towards the very end. If it's a dashboard, what are the KPIs that are relevant for your organization? Once we define that, we can start to build those apps, rapidly deploy those applications using the COTS technology from a configure-first approach. What we've seen customers be successful with is just using the technology as is and being able to configure it to support their specific business needs. By using a configure-first approach, they're going to be able to gain value out of the system in a more immediate time frame. And then you can always look to improve that and refine that. And in some cases, our customers do want to extend and customize. So we have APIs and SDKs at really all levels of our platform to allow our users to extend the software to their specific needs. Okay, so before we open it up to questions, I do want to just kind of highlight some upcoming events that we have. First and foremost, we have the Esri Virtual User Conference. That is July 13th through the 16th. It is opened up to all of our users. There's no limitations in terms of being able to access. Typically, there's a certain number of passes. This year, it is wide open for our users, so we want to encourage you to register for this. It's an opportunity to engage with our product team, with our BD staff, our professional services staff for aviation as well. We also have some webinars coming up. I did mention at the very beginning that this is a part of a webinar series. Subsequent webinars that are coming up is Aviation Charting and ArcGIS Pro. That'll be in September. And then deployable apps for authorities and airports. So how do we create some of those dashboards that we saw at the very end? And those that did not get enough today, there's actually another webinar, Airfield Inspections, hosted by our transportation team. It's focusing on airfield inspections as part of Part 139, which is a US regulation. But keep in mind, it's not restricted to just US regulations. It is a part of a broader set of capabilities that allow us to conduct those safety inspections at the airport. So there's the URL. I'll leave that up for a minute, and then in the meantime, I'll just kind of transition over to Kiyoshi for some questions. I think we've seen some questions come in. Kiyoshi, do you want to just start to run through some of the questions that have come in?
Yeah, definitely. I will do my best. We've got quite a lot of good questions here, so we'll try to get through as many of these as we can. And I'll kind of just go through in the order that they've come in. So these first ones will sort of jump back to the beginning of the presentation a little bit. So one was a question about the spatial reference. I think the X and Y coordinates and the reference used in the ILS data. Not exactly sure the specifics of the question, but maybe we can just address whether the coordinate system of the obstacles and the multi-patch where we're writing our surface with the CNS creation tools, are there restrictions or requirements? I think generally speaking, those features are in the same database for us with the same coordinate system. But I don't know, Amit, are there any restrictions on that?
So in this case, the Navate system that I was using like NAD83 or WGS84 for obstacles. Usually we recommend having the same coordinate system as the multi-patch or the database or the airport at which you're doing the analysis, but the tools are smart enough to figure out what the different spatial references are and do the analysis correctly. If your vertical coordinate system is different, then we do need to make sure that you understand how your data is being written or your obstacle information is there. So as long as you understand how your data is coming in, the tool should be able to handle different coordinate systems.
Okay, great, thank you. Another question is about doing that obstacle assessment, whether we're able to do that for several surfaces at once to calculate the obstacle penetrations for all the existing limitation surfaces. And yeah, I guess whether that's possible. Can we do this for all of our OLS features at once, or is it one by one?
Yes, yeah, you can do it on all of them. Like for the sake of the demo, we just did focused on the approach surfaces, but if you don't have any definition query or any selection, then it will honor all the features on your database. So yeah, it can be done.
Right, and so we'd get an analysis output point for every surface that feature
yes.
that obstacle interacts with, right? Okay.
Yeah, and I show the description, so it will actually tell you this obstacle intersects your horizontal surface for IQNX 14 or IQNX 15. So it will give you all that information when it writes out the information.
Great. Right, and I think this also ties into another question that I'm seeing about, are there tools to create some maps to map out the most restrictive surfaces for overlapping surfaces? Does that make sense?
So, yeah, I think I understand. So if they have multiple overlapping surfaces, they want to find out the lowest surface. So they know if they are penetrating the lowest surface, then it's an obstruction. And yes, at the last release, we added a new tool called OIS intersections, which takes in multiple multipath surfaces, and it will find out the lowest surface and write it out to your output. So yeah, that will be done. And yeah, we have seen quite a few requirements for around that.
Great, thank you. Let's see. The next question here is about the LiDAR data in terms of availability of the LiDAR data. And so I'll go ahead and take a stab at this one. I think the data you're using, Amit, we obtained that from the NOAA LiDAR survey, correct?
Yes, that's correct.
Okay, so I'm going to go ahead and paste a link to that in the chat. That's just something that's available from the National Oceanic and Atmospheric Administration, NOAA, here in the States. So it's primarily available around the coasts of the United States. So depending on where you are, that may or may not be useful to you. Otherwise for doing that sort of analysis, you'd want to obtain a LiDAR for your airport directly.
And we have seen quite a few cases where we have used a drone and using drone to map to collect that LiDAR information around the airfields as well.
Oh, that's a good point. Thanks, man. Next question is about training and what training is available for the different functions of the toolbar. So again, I'll post another link to the chat or in the chat to. We do have a training course that goes over some of the materials that were covered here, primarily the obstacle analysis and OLS creation and things like that. So that's in the chat as well. You can look at that course offering. I'm not sure when our next offering will be, but that's
that's a good question, and that's one that actually comes up quite a bit. And it can be somewhat difficult, especially in these times right now where we're not doing on-site classes or in-room training classes where everything is being conducted virtually. So it makes it a little bit more challenging. I don't know whoever posed this particular question, if they're in the US or if they're perhaps in Europe or Asia. That makes certainly some challenges around that, but we do look for opportunities to have open enrollment. So we're looking at that right now, and I think we'll just have to go back and see if we can identify who's asking this question, where they're from, and in some cases it may make sense to involve our local distributors out of that region for support of the training.
Great, thanks, Jonathan. Let's see, next question here is about, I just lost my cursor there, is about the concept of shadowing. So in the case of the Type A obstacle chart, the train obstacle profile that we created, is it possible to skip obstacles that are in the shadow of other obstacles? And again, I can go ahead and take a stab at this one. I think that, Amit, this is something that currently that we haven't incorporated in the tool yet, the ability to kind of, ignore obstacles that penetrate the surface if they're behind a taller obstacle, but it's something we may look into in the future. Is that safe to say?
Yeah, I think it's not currently in the software, but that's on our roadmap.
Just kind of thinking about when you published that 3D scene, Amit, one of the options was to show the shadows. Now, this doesn't give you kind of the perhaps a level of accuracy in terms of or details in terms of the analysis, but oftentimes you can actually, based on the obstacle, if you actually have kind of these volumetric shapes of the buildings, you can actually show kind of where the shadowing is occurring if you place the sun at the right angle and things like that. So that can give you, at least from an initial standpoint, a high-level review of, okay, does this obstacle exist within the shadow of another one based on a particular approach and angle that you're looking at.
Right, that's a good point. You know, there's other tools too, I know, throughout the platform that allow us to do, you know, line of sight calculations and things like that as well. So that might be something worth looking into for us is you know, looking at whether we can use that technology or that functionality to kind of help identify these things that would be, you know, quote unquote shadowed by a taller obstacle.
Right.
Next question here is about what do we do with the CNS surfaces after we've done our analysis. The question is, sorry, so many questions coming in, I'm losing track here. So what action do we take in you know, when we find a CNS penetration? Do we need to conduct additional assessment to be sure that the CNS signal is not affected? Can this tool perform this task? So unfortunately, I think for us right now, the tool is primarily used to identify those situations where a penetration or potential penetration occurs. We don't have that kind of next step of you know, solving that issue. But you know, that being said, you know, some of the workflow stuff and things that Jonathan has shown in the webinar can be used to, you know, I guess provide the mechanism for that communication, right? Of saying, here, I found these issues. Now let's send this off to the next team to kind of take action and solve that problem, or further investigate whether it's, you know, it's actually a significant issue. Anything to add there, Jonathan or Amit?
No, I think that was a good good synopsis.
Great, thank you. Let's see. Yeah, so this next question I have a little more clarifications. The question was, can the tool evaluate collected obstacle data to ensure the selected obstacle requirements in 18B were met? And this is with respect to the select obstacle requirements in 18B when performing an evaluation of the vertically guided OIS. For example, the highest man-made object on each side of the runway centerline in the approach surface. I may need a bit of time to digest that one, unless that rings true to you, Amit.
No, I think is this being in regards to how the data was collected, or if all the attributes that are needed for the obstacles were collected? Then we do have some data checks or data review checks, which can check the validity of information that's been collected for a given obstacle. But yeah, I think we might need some more details about the particular question.
Okay, yeah, that's great. I think yeah, for Mark who submitted that, we'll go ahead and follow up with you offline if we can. Next question is about the elevation surface data. So for the OIS analysis, which is the, I guess, what's the best surface? What's the best elevation surface to use, or in terms of elevation data? And so I guess maybe I'll say, the best elevation surface to use would be, you know, whatever you consider to be your authoritative surface model. So that being said, there is you know, ArcGIS Online has a terrain 3D, sort of a world surface, world elevation model that can be used, but obviously there's going to be, you know, accuracy issues there, depending on, you know, where that information was kind of aggregated from. So I think the short answer would be you know, whatever you consider to be your authoritative elevation surface or surface model would be the best surface to use for the most accurate assessment. Okay. So let's see the next questions. Some questions about trial versions. We'll get to those offline. Okay, so the rest of these questions have come in since we've started the Q&A question, so I haven't had a chance to think about any of them, so we'll just kind of take a stab at it. Let's see, so is it possible to program predetermined surfaces in ArcGIS for obstacle management? Maybe Amit, you could talk a little bit about the Kustomize OIS utility with that respect.
Okay, so I'm not sure if this thing is about Kustomize OIS, but yeah, I can take a stab at this. So as Kyoshi mentioned, and Jonathan also alluded to it, that we do have a Kustomize OIS utility which allows you to change the parameters that are used to create those OIS surfaces. So it's available through the Aviation data package that should be available if you have access to ArcGIS Pro. You can get those data packages and you can customize those parameters, and you can save it out as a JSON file. And anytime then you run your tool, you can point to those JSON files and it will use those updated parameters. And once you, from what I could understand from this question, I think they might be asking about if you have defined set of OIS surfaces that you want always your analysis to be run against. Then in that case, if your map or scene is using that layer as the source, then you can always run the tool with those OIS surfaces every time, and it will honor and do evaluation against those OIS surfaces.
Gotcha. That's a great point, Amit. It's a good take on that question. I guess just to add to that too is maybe the point that a lot of our tools, or all of our tools, particularly the tool you use for the analysis, are they're geoprocessing tools, right? So they can be kind of wrapped up into a model or a Python script where that could be kind of hard-coded as well, right?
Yes, that's correct.
Excellent. All right, Kyoshi, maybe just let's take one or maybe two more. Okay. We're coming up against the top of the hour. What we can do is we'll be able to consolidate all these questions, and when we send out an email, a follow-up email for the recording, we can include some responses to these, because we've had quite a few questions come in, and we're just not going to be able to get to all of them. So maybe just one more question, Kyoshi.
Okay, great. Well, I'd see one that I've seen a lot has been about the webinar recording. So I'll go ahead and just address that before I get to this sort of last question, and say yes, we are recording the session, and that will be shared with you guys in the coming days once you've had time to kind of save it out and process it and everything. And maybe for this last question, Amit, I've seen it kind of variations of this question pop up a few times, and that's just about kind of the functionality and with respect to the release and things like that. So which, I guess maybe you can just talk about if any of these tools are what versions they're available in and things like that, where we're at in terms of the pro release cycle.
Sure. Yeah, so I was running the demos through 2.6, which should be coming out after UC. So the only new tool that we added for that release would be the PAPI and LCS. The analysis tools that we showed here, they were part of the 2.5 and 2.5.1 release. So if you have 2.5 release, then you should have LiDAR analysis tools and obstacle analysis tools.
Okay.
OIS intersection that we mentioned, that was released at 2.5, but yeah, most of the tools that we showed today should be available today for most of our users.
Okay, excellent. I think, yeah, let's looking at the clock, we're right there at 9 o'clock. So I think, as Jonathan mentioned, the rest of these we'll try to address offline and get a response out to everybody.
Yeah, thanks, Kyoshi. Thanks, Amit. And really, thank you, everyone, for being able to attend the webinar, Enhancing Collaboration for Obstacle Assessment. As Kyoshi mentioned, this webinar is being recorded. It will be made available in the next couple of weeks, and we'll follow that up with the answers to a lot of the questions that we've received today. So again, we thank you for attending. We hope you have a good rest of the day, afternoon, evening, wherever you may be dialing in from. Thank you, everyone.